Okay, so metabolism. I gotta quit rubbing my hands. I'm sorry. I gotta quit rubbing my hands when I do that. Metabolic pathways. Right? So metabolic pathways. Here's what we are learning as biology is constantly evolving. It's a science. We're always learning new things. We're always learning how species have evolved. And what we find is we find some commonalities between how organisms metabolize what they need to. What are their metabolic pathways? Most species have their own tools on board for processing the macromolecules they need to, but there are similarities. And research has traced back and shows that there's a common metabolic pathway shared by all life forms, meaning we should be able to trace back to a single ancestor. Now, will we ever find that fossil? I don't know that. I'm not the person to ask about that, but that is the current trend. That is what research is currently showing us. Okay, so, all right, I found some fun GIFs for us here. So what I wanted to talk about here is let's talk about energy and let's talk about the laws of thermodynamics, which is in your text. Kinetic energy. So if we talk about types of energy, right, so there are different types of energy. Now, these are not, the first couple I'm going to talk about here aren't necessarily the types of energy we would see in cells. There are some moving parts in cells, and things are going to have their own kinetic energy. But kinetic energy, we would talk about a lot of times in a physics, maybe a chemistry class, that is energy of motion. So whether that's movement, what we call translational movement, maybe some kind of rotation, or even vibration. It's based on the speed of the particle or the object, and it's based really on the speed squared. So when the speed doubles, the energy quadruples. And then you have we call the GIF image is a little slow on us, sorry, but you have what we call potential energy. That is energy that is transmitted by some kind of a force. And so if we allow that force to transmit the energy, then we can increase or decrease the energy depending on which direction the force is going. In a case of gravitational energy, as you see the roller coaster there, when an object is at a higher location and you allow gravity, the gravitational force, to add energy to it, and it's imparting or it's changing the potential energy. That potential energy can also be stored in springs and other materials. Sometimes we can have some proteins that are folded or bent in a specific way, and they can store potential energy. But most of the energy in molecules is going to be chemical energy, or at least for us in a biology course, what we're going to be most interested in is the chemical energy stored in the bonds that form the molecules. So in the case of octane, we like using octane in cars because there's a lot of energy stored in those carbon-to-carbon bonds and carbon-to-hydrogen bonds, and because it's in liquid form, that energy is packed in a really dense package, so it's really easy to transport. Organisms also can use these bonds, those stored in between carbons and hydrogens, and that's what's stored in carbohydrates, is the energy that's bonding the carbon, hydrogen, and oxygens together. Once we release that or once we break those bonds, that releases lots of energy that can be used in the cells to build up proteins and lipids and other things that we need to build up. All right, so conversion of energy from one form to another. Again, there's multiple forms of energy. We just talked about that. What allows those forms of energy to change? And it's governed by a science we call thermodynamics. Now, there's actually 4 laws of thermodynamics. I actually regularly teach an engineering course, engineering thermodynamics. It's kind of my specialty is really more of a food engineer is kind of a lot of my background is. And so, and I'm coming up on my end of my 5 minutes. So I'm going to have to pause here and come up on the next video. We'll talk about the first and second laws of thermo.